All right. Hi, John. Thank you so much for joining us on this episode of the Energy Transition Podcast. We're so happy to have you here.
My pleasure.
So can we start our conversation by learning a little bit about you? Can you tell us a little bit about your career, your current role as the President and Chief Technology Officer of Hephae Energy?
Sure. I started my career in the actually started my career in aerospace in the mid 80s after a degree in engineering science from University of Oxford in England. But after a couple of years, I came to the conclusion that drilling wells was more exciting than designing jet engines. And so I started off designing bits for a company called Hycolog, which is now Reed Hycolog, part of NOV, in a place called Stonehouse in the southwest of England. And over the years, I kind of specialized in drill bits and then in drilling tools. Ran a team that developed one of the first rotary steerable systems that became Schlumberger's power drive system. And over the years, worked for Schlumberger, NOV, Weatherford, Altera, and ABB in a variety of roles, probably about two-thirds of the time in engineering and about one-third of the time in sales or operations project management. I left my full-time employment with Weatherford in 2020, which happened to be around COVID time. And my job was visiting people and going to conferences, and there was suddenly nobody to visit, no conferences to go to. So we agreed that I'd depart and start to do a bit of consulting. And I actually wrote a couple of books on innovation and started to look at the geothermal industry with a friend of mine, my co-founder, Steve Crace, who's now CEO of Hephae. And we founded Hephae in 2021 because we saw a gap in the market, we thought, for higher temperature drilling technology to enable hotter and deeper geothermal wells to be drilled. And it looks like, and we can maybe talk about it over the next few minutes, but it looks like our timing was good. So I don't know if that was clever or lucky or maybe a bit of both, but it looks like we timed it well. It took us a couple of years to get our first funding. We got our first funding for Hephae in March of 2023. And then we kind of hit the burners then and started doing our technology development. You may have seen we just announced our most recent funding round in September. The round was in September. We announced it last month in November of this year, and that's given us the money to build prototype tools to have tools in the ground drilling above 200 degrees Celsius by the second quarter of next year.
That's incredible.
Thank you.
Well, you've already given us a good kind of history of how you got from oil and gas into stepping into geothermal via the drill bit technology with regard to that. Uh, and can you tell us a little bit about what you think that business opportunity is for Hephae going forward? Obviously, you want to develop the technology and prove that it works, but from there, how does it influence the advancement of geothermal?
Well, yeah, it's a good question, and there's maybe a few answers to that one. And one of the things to build on what I said about why we got into geothermal, we both started to look at geothermal. A few people advised us, and my initial reaction was fairly, not terribly enthusiastic. I thought, okay, I've come across geothermal energy before. You find it in places like Northern California, Iceland, Italy, and New Zealand. Very small geographic areas where you've got a combination of heat close to the surface and fractured rocks and natural like aquifer reservoirs, and you can drill for a combination of hot water and steam and generate electricity. But I don't see how that's globally scalable. And then we started to dig a bit deeper, and we came across technologies that we hadn't really heard of before, but which we're now very familiar with. EGS, enhanced geothermal systems, and AGS, advanced geothermal systems. We are basically creating artificial reservoirs in hot, dry rocks. So instead of going for fluids, you're actually going for the heat, and then introducing fluids to transport that heat to the surface. And we realized that there was a lot of analogs between unconventional oil and gas drilling and the boom that had seen and the technology that had been developed for that over the last 15 to 20 years. And unconventional geothermal wells could look very similar. And we saw the opportunity for a number of horizontal wells that might use fracking or might not, and that might depend on where you are in the world, and which would basically use the same technology as has been developed for oil and gas, but just at higher temperature. And then the other thing we saw, which really kind of closed the deal for us, was we used the Department of Energy in the US has got this beautifully named model called GETM, which is I think it's the Geothermal Energy Techno-Economic Model, something like that, some kind of contrived acronym. And you can use that to calculate the levelized cost of electricity from a geothermal well, given a whole bunch of assumptions. And so we modeled lots of different scenarios and cases and then normalized it. And we saw there's a very steep drop in the cost of electricity when you go from 170 degrees Celsius, which is kind of where oil and gas wells are drilled at the higher level, to between 210 and 250. So going from 170 to 210, you get about a 25% reduction in the levelized cost of electricity. If you get to 300 degrees Celsius, it's something like a 70% reduction. So those are huge potential numbers that could be the difference between like life and death for sanctioning a geothermal project. And we realized if we can create well construction technologies that work at higher temperatures, then we can open up that market and make geothermal much more globally applicable. And so that's what we did.
That's really impressive.
No,
Um,
that makes perfect sense. If we start chasing heat instead of fluids, heat's everywhere. Except it just depends on how deep you have to drill.
You could do it anyway, yeah, and that means that you can build your power plant close to the it doesn't have to be close to the source of energy anymore, like a wind or a solar plant might be. It can be close to the point of use. And so if you have an industrial facility or a large residential community, you can build the power plant for it adjacent. And so then you avoid problems with grid congestion or with the cost of sort of putting wires halfway across the country. And one market that seems to be ripe for it, where you have seen some interest in announcements recently, is sort of AI data centers, technology companies who are going to need vast amounts of electricity. Seen some estimates that the electricity consumption of the United States might increase by 20% between now and the end of the decade as a result of AI, machine learning data centers. And I don't think it's any coincidence you're seeing things like Fervo, who's one of the pioneers in unconventional geothermal, teaming up with Google, Meta entering into a deal with Sage, which is another sort of geothermal, unconventional geothermal pioneer. So I think for if you're running a data center, one of the most valuable things you've got is 24/7 availability of energy, which means that, yeah, nuclear is potentially attractive to them. But if they're going to stop burning large amounts of natural gas, geothermal is the obvious play for them to get into.
yeah, and your resume online says that you're a geothermal enthusiast. What makes you so enthusiastic about geothermal specifically?
I think it's a lot of the stuff that I just mentioned, but if you put it together, you need if we're going to stop burning natural gas in particular for and I'm thinking more about electricity production at the moment, then we're going to need a source which is sort of plentiful, which geothermal is, which is always available, which geothermal is. It may not be renewable, but there's plenty of heat down there to keep us going for, sort of probably hundreds of thousands or millions of years. So it buys us a lot of time to develop other energy sources. It is everywhere, as Jim just said. It's just a question of how deep you go, and it doesn't depend on the weather or the time of day. It's super reliable, and that means that and also because it can be found anywhere in the world, you don't anymore have nations that are energy rich and nations that are energy poor. So that potentially helps to avoid the requirement for conflict in the future or the potential for conflict. And I was at a conference recently. I don't remember who it was, but somebody made the point. if you have energy, you can solve all of the problems. If you've got energy, you can solve food, you can solve healthcare, you can solve transportation, and so on. So being able to provide plentiful energy anywhere on the planet looks like a real win, and one that probably hasn't got the attention and the airtime it's deserved until maybe the last couple of years.
Yeah, and from your with your background, what are some expectations to have that shift from oil and gas and focus more towards geothermal? What are some of the expectations for that?
It depends on who you talk to. Some of them are very big. I mean, we expect there to be significant growth, probably exponential growth in the number of geothermal wells drilled, probably starting around 2027, 2028 time. So we expect to see a lot more wells drilled in the last few years of this decade. I'm going to defer to a podcast that I listened to, or a webinar, I guess it was, that I listened to earlier this year, that was run jointly by Schlumberger or SLB. It's one of the big oilfield service companies, and Ever, who's a Canadian company drilling advanced geothermal wells in a variety of places. But I think the highest profile project at the moment is in Bavaria, in Germany. And this particular webinar was about the German project. And on there, Ross Loudon, who's SLB fellow, who's one of their like technology gurus, made the prediction that in a few years' time, he didn't specify quite how many, but in the not too distant future, geothermal drilling could be bigger than oil and gas drilling. If you think at the moment, the oil and gas industry maybe drills 70,000 wells a year, give or take, if it depends on a number of factors, but that kind of number. That implies that in the not too distant future, we could be looking at drilling 30 or 40,000 geothermal wells a year. And I had to catch up with Ross afterwards and say, "Did you really say that?" And he said, "Yeah, I said it because I believe it." That's at the high end of the ranges of expectations I've heard. But we're looking at thousands, probably a few thousand wells a year being drilled in a few years from now, which is a big step up from the two or 300 hydrothermal wells that have been drilled historically over the last decade or so around the world.
Well, yeah, that's we're really starting to see the shift now, especially with the change in energy demands. I feel like it's really pushing
Yeah,
that shift in the energy transition.
yeah, and I think geothermal is a perfect solution to that because it ticks all of those boxes that we talked about earlier.
I guess, talking about more geothermal wells than oil wells, that's a real paradigm change. And so necessity is the mother of invention, as that phrase goes. So if all of a sudden now we need geothermal for all the good attributes that you talked about, and it can be anywhere, which maybe can address the issue of energy poverty in some nations that may not have fossil fuel resources, or it's a long way away to transmit the energy. Um, so if kind of the necessity here now is to reach the hot rock, where and to go beyond oil and gas technology, which is obviously, as you know from your career and your experience, has developed incrementally to get deeper and deeper and hotter, and we don't burn out the electronics like we used to at 150 degrees. Um, but can you tell us a little bit about what you described as the 200 degrees C challenge, and not just I guess, the metallurgy on the bits, but the whole drilling system? How can that all survive at hotter and hotter temperatures that we're aiming for?
Yeah, I describe it, and this might not be quite the right term, but I describe it almost as like a techno-economic challenge. There are technical difficulties, but there's also economic reasons why it hasn't been addressed by the oil and gas industry over the years. Um, I mean, I joined the oil and gas industry in 1986, and at that time, the first MWD tools were, I think they had just emerged. And in the 1980s, early 80s, late 70s and early 80s, the temperature capability of an MWD tool was maybe 85 degrees Celsius. And I can't convert that into Fahrenheit in my head. So I'll talk in Celsius, and because to some extent we're talking about relatives anyway. And that was based on availability of commercial electronic components. Um, it quickly moved up to about 120 or 125 degrees Celsius because you could get like military parts which would work at those temperatures. And I remember in 1996, Sperry Sun, as was, showcasing the first 175 degrees Celsius logging while drilling tool at the actually at the aquarium in New Orleans at one of the SPE conferences. And so we got to 175 degrees Celsius in the 1990s. And now, nearly 30 years later, we haven't really moved very far. There's some tools that are rated to 185 Celsius. There are a couple of companies that have got tools rated to 200 Celsius, but only a handful of tools. And the implication of only having a small number of tools is they're pretty quite expensive to build. And, I was working for an organization a number of years ago that had the opportunity to build a tool for drilling oil wells above 200 degrees Celsius. And I was very much opposed to it because I couldn't see where the market was. I said, why spend all this engineering money on a market that's got like 4 rigs? Which is kind of ironic given what I'm doing now, which is suggesting that we do develop high temperature stuff for geothermal wells. But I don't think there was ever really much of a demand for oil and gas tools to drill above 200 Celsius. So nobody built any. And the techniques that we use to get them from the low hundreds to up to about 175, 185, they kind of run out of steam as you get towards 200 Celsius. And so you need a different approach. And our first question to ourselves was, well, can that be done? Can you do it differently? Can you have a different approach? And we built an engineering team with electronics group in Houston, Texas, because there's a very good ecosystem there for high quality, high reliability electronics, not just oil and gas, but also space and medical. And we built a mechanical engineering team who also does all of our thermal modeling in a place called Bilbao in northern Spain. And we chose Bilbao for a number of reasons. But one of the reasons was that the people we employed there know nothing about designing drilling tools. And because they don't know anything about designing drilling tools, or they do now, they didn't realize it was impossible to do stuff that would work above 200 Celsius. And so they just did it. Because if you don't know something's impossible, it's quite often easier to do. And by completely redesigning the way that the electronics is mounted, and by rethinking the way that we take heat away from the components on the boards, and the way we manage heat, and the way we take it to places where it's not going to do any harm. Unfortunately, thermodynamics doesn't allow you to destroy heat, but you can move it. And so we're able to move it to places where it's going to be relatively harmless. We've been able to break that 200 Celsius barrier. We also got a lot of comfort from looking outside the oil and gas industry and looking at places like space. You look at NASA and the work that is being done by JPL, for example, on spacecraft that travel outside the moon's orbit. They're looking at a Venus lander where their electronic specification is 480 degrees Celsius. They have components on deep space probes that are working at 500 degrees Celsius as part of the power supply for the sensors, the cameras, and communication systems, and so on. So we realized it actually can be done, and there are technologies that allow you to do it. And what we have to do is we have to take those technologies and we have to take our knowledge of how to design measurement while drilling, directional drilling tools, and put them together. And if we can fuse them together, we can take the technologies used to drill unconventional oil and gas wells up to, between 175 and 200, and we can drill wells with temperatures between 200 and 300 Celsius. Starting at the lower end of that, starting at around 210, and then working our way up. And it was realizing that the reason it hasn't been done is not because it's impossible, it's difficult, but the reason it hasn't been done is because nobody ever needed it before.
Well, I think it's a great case history about moving from incremental improvements, which maybe we were going to go from 170 to 175, to reimagining the system and coming at it from a different direction. And the reimagining, we in several of our energy transition talk episodes, we've heard people talk about reimagining, not just incrementally improving. things like that, and to take a step back, to go to Bilbao, to go to whatever it is, and try to come at this from a different direction. Just there was a, I know there have been a couple of almost geologic exploration wells. The Russians have drilled one, the Chinese are drilled one. They're trying to go to almost near mantle, kind of depths. Are there anything from those efforts that help kind of come back again to give you a look from outside the normal industry?
I don't know how hot those that they got. So the short answer is no, although the maybe, but we haven't looked at it in depth. Certainly for the work that Hephae is doing and the way that we're looking to develop our equipment, the way that people are likely to drill unconventional geothermal wells, we think, if you look at what Fervo and Ever and companies like that are doing, is they will kind of look like unconventional oil and gas wells, maybe a bit deeper, maybe a bit hotter. One place where we have seen a lot of useful work done over the years is Iceland, the IDDP wells, which were the like sort of deep sort of geothermal exploration wells that were drilled in Iceland over the last decade or so. And even there are some crazy people at the moment trying to drill into magma in Iceland, and some really interesting stuff could come out of their work as well. And the stuff that was done in Iceland is all been kind of very much focused on geothermal energy and its exploitation, rather than drilling, sort of super mega deep boreholes for the sake of it. So we think in terms of navigation, wellbore quality, wellbore positioning, and making sure that adjacent wells are the right distance apart and stuff like that. We can take pretty much all of that know-how from what the oil and gas industry's done, and just sprinkle some high temperature kind of magic dust on top of it to make it go deeper.
I think there's a lot of cases where oil and gas drilling and space technology, NASA and European Space Agency and things like that, where you said, if I had to drill a well on Venus, how would I do it? So that's reimagining kind of the system.
Yeah, yeah. And yeah, there's some fantastic technology available outside of our industry if we go and look for it, and then it's just a question of combination. And most great innovation, you talked about innovation earlier, is taking existing ideas and combining them together in different ways. You quite
Broaden
often
your perspective.
do.
Yeah, broaden your perspective.
Yeah, yeah. You don't have to come up with new physics. You just have to take existing stuff that other people have done, and I should say broaden your perspective and bring in stuff from a wider kind of base as the technology feedstock that you use to develop your products.
Well, thanks.
Yeah, and if we look at the geothermal systems in like the Western US, they're typically more focused on like generating electricity. But in Europe, they're also looking at district heating needs. Could you help us understand the difference?
Yeah, it's that's a really good point, and I think that there's quite a bit of history in Europe. You mentioned Iceland earlier on, and also in other parts of Europe of using geothermal energy for heating. In the Netherlands, for example, I think there's some use of geothermal energy for crop growing and stuff like that. Um, if you start to think deeper and you get to the point where you're drilling for electricity, then you're going to produce a lot of heat as a byproduct. And it's kind of nice to do something with that heat. There's a, you may have seen it on the news recently. There's a resort in Iceland close to Keflavik Airport called the Blue Lagoon. And it's been in the news because their car park was just invaded by lava as a result of the latest eruption in southwest Iceland. And the Blue Lagoon is a resort where you can go swimming in these sort of hot geothermal pools. And I've been there. It's great. I recommend it to anybody. But the heat is a byproduct from an adjacent geothermal power station. So they're putting the heat effectively to good use. Um, when you have that heat as our product, if you've got a population which is close to the where the power is being generated, you can take that heat and you can use it for the benefit of the population in terms of district heating. You can use that to improve the economics of the project because if you sell heat as well as electricity, you're getting more revenue from the project, and therefore the return is going to look better. You can potentially use it to try and gain social license. If you any place where you try and generate energy where there's a large population, residential population, there's bound to be some kind of objection to it. And so gaining social license is very important, not to be underestimated, pretty much anywhere in Europe in terms of being able to get permits to drill geothermal wells and providing heat to the local community, um, not necessarily for free, but maybe discounted, uh, could go quite a long way to helping with that social license. But if you don't do something with it, it's just going to go into the atmosphere, which and I'm not going to say that's a major contributor to global warming, but it's nice not to waste that energy having produced it. Be good to turn it into something useful.
Yeah, and what are some of the opportunities and challenges with today's, development and implementation of geothermal?
I think a lot of it is kind of chicken and egg problem, which is that it has had a reputation for being costly, and geothermal wells have a reputation for being costly to drill. Um, I think there's a couple of ways in which those challenges can be met and the cost can be reduced. And one of them is by importing technologies that have been developed for the oil and gas industry. Look at the cost curve for unconventional shale wells in North America, and they're between 3 or 4 times less expensive to drill now than they were 15 years ago. And you can make the same kind of savings in drilling geothermal wells. And to some extent, people like Utah Forge and Fervo have shown that. I mean, they've both published the extent to which they've been able to reduce the cost of drilling their wells, if you like. Um, so that's one aspect, and the other aspect is just scale. And if you start to drill wells at scale, the cost of drilling the wells is just naturally going to come down. Everything gets cheaper. You know, people get more good at what they're doing. I think if you're not drilling for geology, you're not drilling for water. You're drilling for heat. You're going to be drilling for geology, but you're going to be able to choose where you do it. So you're going to be able to do kind of factory drilling in the same way as you did for unconventional oil and gas. And so scale should contribute to massive cost reductions. And that means that the industry just needs to be seeded. And it's good I think the US Department of Energy is probably ahead of the game when you look around the world in terms of supporting the industry. It's one of those cases where if a small number of high profile sort of pilot studies can be done and pilot projects can be done and prove the feasibility of it, that will seed an industry and scaling will take care of cost. So I think I'm much more confident about the future now. If you'd have asked me this question a couple of years ago, I'd have been really pushing hard for somebody to drill the first wells. I think we're almost past that now, especially when you look at what Fervo's doing in the Western United States. But the more the industry grows, the cheaper things are going to get, and that's why I think there will be an inflection point, and you'll see exponential growth because you get past that point where people realize the cost is coming down, and then we'll be kind of off to the races.
Yeah, I think you brought up a lot of great points, about the transition and really like just no pun intended, full steam ahead.
Yeah, and I think we were right on the cusp of it. I think when we started the company, it was a question of is this going to happen? And now in our vocabulary, it's this is going to happen. And you can sense that the media doesn't pick up on it as much as they should, and you don't see as much in the press about it as you should. But you do see more than you did last year, and last year you saw more than you saw the year before. So yeah, watch this space. It's coming.
Well, we want to really thank you for your time today. As you said, it's good. It's important to be clever and lucky at the same time. So maybe you've got that sweet spot with regard to this. Uh, Kind of coincidentally, my daughter was visiting Iceland and swimming in the Blue Lagoon about 2 days before that. that latest eruption that
Oh, really?
put lava in the car park. So she had a first chance at seeing it really up close and almost two more, with regard to all of that. But what we wanted to try to close with, I mean, you've done a great job of covering this idea of new opportunity. And I really like your idea of it's a economic and engineering kind of challenge. You have to be able to do the good engineering, but then there has to be a market for it, rather than just a pure science project, with regard to those things. So maybe both of them, with the data centers, with the cooling needs, with the yeah, a number of new kind of applications of, you can't run one of these new hyperscaler AI data centers on sun and wind because of the intermittency with regard to those. So you need a base load, but you need a clean base load, and
That's
geothermal
exactly right.
maybe only with the idea of nuclear, kind of fits that bill. So maybe it's something that's just timing, but uh, you've answered our questions, and it really helped give us a lot more insight into things. But is there, just to finish up, and we'll give you an opportunity, is there anything that you think is important for our audience, which is a general one, not a technical specialist one, a general one that you think that we need to understand and know about geothermal and about maybe some of these enhanced systems, not just the volcanic ring of fire, sort of things we've been used to.
I think there's maybe, yeah, maybe one point about the about geothermal energy, and maybe one point about the industry and how it's going to be delivered as well. And when you compare geothermal energy with nuclear, I mean, they will both provide base load. They could probably both do so economically. They both require slightly more patient investment than oil and gas. We did some like just back of an envelope modeling on oil and gas wells, and the amount of energy, and this is before conversion efficiency or anything like that, just the amount of energy in a barrel of oil that comes out of a typical sort of shale well in Permian Basin. And we looked at drilling a similar well and the amount of energy that might come out of the geothermal well. And the oil well maybe depletes in 18 to 24 months, and it might take 10 or 15 years to get the same amount of energy from the geothermal well. But it keeps going after that. It doesn't stop. And so ultimately, your return is better and you get a lot more production from the well, but it takes longer. So it just requires a slightly different approach in terms of capital and who the investor is. But when you compare it with nuclear, which is maybe the closest competitor in terms of sort of 24/7 baseload, you could imagine that a geothermal well is going to be a lot quicker to drill. It's going to be a lot less expensive to put a power plant together, and you can probably build kind of smaller, more nimble sort of installations to provide the energy needs that whichever consumer is going to be looking after. And then when you think about scaling, I mentioned Ross before and his prediction of the oil and gas drilling industry effectively converting to geothermal. And that brings up a point that a lot of the infrastructure you need is there. The oil and gas industry has a number of layers in it. There are operators, there's the Shells, the Exxons, the Aramcos of the world who actually basically own and produce from the assets. You then have drilling contractors who are the guys that have the rigs that come and provide the rigs that are used to drill the wells. And then you have service companies who might do directional drilling services. They might place the well in the right place. They might put completions equipment in the well so that you can produce from it in the right way. They might put equipment in to enhance production, like pumps or other lifting devices. All of those companies, especially the drilling contractors and the service companies, could well be the same companies. It's the same skill set. It's a lot of the same equipment. The only thing that changes really is geology. The rock is a little bit harder to drill, and temperature. It's a lot hotter. And so it's really just sprinkling a bit of extra technology on top of what's already a very successful and dynamic industry. And that's why companies like Hephae have been sort of founded to do just that. And so our mission is not to go and replace drilling contractors or replace service companies and drill wells. Our mission is just to provide the technology that all of those guys are going to need. And with that technology, I think they can take their business models, and a lot of their business models are directly transferable to geothermal, which is one of the reasons I think it could take off really quickly, because a lot of the infrastructure you need and a lot of the people you need and the skills you need, they already exist. They just need to be adapted slightly.
We may need to change our geology classes to emphasize a little bit
Definitely, yeah.
igneous and metamorphic rocks and sedimentary. But other than that, it seems like a really good fit.
I think it is, yeah. I think it's a really good match, and in certain parts of the world, in the UK, for example, oil and gas is becoming a sunset industry, and it's a great opportunity for sort of skills transfer and for maintaining employment and maintaining sort of important technology base as well. That if the industry can pivot, or if geothermal and oil and gas can find ways of living side by side in terms of sharing technology to an extent.
You mentioned that the Department of Energy in the U.S. test bed, and you're probably thinking about the Forge Center in Utah, and
Yeah.
that's where you could test a lot of these things in their early stages. Are there other places like that around?
There are others that are being talked about, and I probably shouldn't say too much because I'm not sure how confidential some of the discussions are, but I'm aware of other centers being talked about in the Americas. There was just actually a public announcement. The Alberta government is looking at setting up a similar kind of location in the next couple of years. And I think that was publicly announced this week or last week. I'm aware of stuff going on in the UK that might be looking at setting up something similar as well. And people have seen that model and realized it's a good model. So you should see people copying that in locations around the world.
And it's a useful part of your technology maturation curve to have a place to try it out first, right?
Absolutely, yeah.
Well, we want to thank you so much for the time and the knowledge and insight, the reimagining drilling systems. We'll be looking forward to your next Beyond 400 Degrees paper, pretty soon with regard to reimagining it. You don't know that you can't do it, so that you try it.
We're already starting to think about how we'd get there, but yeah, watch out for that one.
Well, thank you very much for your time.
Hey,
Yeah,
thanks for the opportunity. It's been great talking to you guys.
Thank you so much for joining us for the Future of Energy. Special thanks to each of our guests today and to our technical wizard, Abhi, for his important contributions to this episode. Don't forget to subscribe to our podcast so you can automatically get access to all our new episodes. You can find us on Apple, Spotify, YouTube, or wherever you get your podcasts.